In this video, I'm going to discuss the consecutive XOR problem which occurred in today's CODECHEF challenge. You're given an array of size n and you're permitted to perform the operation on a of I, that is a of I XOR x, and replace, okay, let me write it, replace a of I by a of I XOR x. But once you do this, you also have to replace a of I minus 1 by a of I minus 1 XOR x. Okay, this is the basic thing. So now after done all these things, you have to check if all the elements of the array can be made equal or not. Now this may seem as a very difficult question, but there is a very simple logic behind this. Okay, first of all, you have to run a loop from I is equals to, let's say, 1 to I is less than equals to n minus 2 and I plus plus. Okay, and you have to make ARR of I plus 1 is equals to ARR of I plus 1 XOR ARR of I XOR ARR of I minus 1. Okay, this whole thing we are going to make XOR. Okay, now the reason behind this is what we are going to do is make ARR of I minus 1 equals to ARR of I. Okay, so if we want to make the previous number, okay, the previous number equal to this number, then if we XOR both of them, then we get the amount that we need to XOR it. Okay, then we get the amount, the value that this is basically, this thing is basically this x over here. Okay, and then we are going to XOR it with AR of I plus 1 because we are going to change AR of I, and then what we do is change AR of I. Okay, change AR of I is equals to AR of I, we are going from this to this, so AR of I is equals to AR of I minus 1. Okay, and done with this. Okay, done with this loop once. Then again we are going to run a loop from I is equals to let's say the opposite. Okay, the thing is going to be opposite, that is n minus 2 to greater than equal to 1 j minus, sorry, let's, for this case, let's say it is j. Okay, just changing the variables. So this is growing forward and this thing is going to be going backward. Okay, backwards. And in this loop we are going to make the same thing. Okay, the basically it is the same thing. Okay, the same changes, that is AR of j minus 1 is equals to ARR of j minus 1 XOR of ARR of j XOR ARR of j plus 1. Okay, done this, and then change AR of j is equals to AR of j plus 1. So in the previous thing we were doing this number is equal to the previous number because we are going like this. Okay, we are going like this, so we are going to make for this case we are going to make this number equal to this, then this number equal to this, then this number equal to this number equal to this, and when we are going backward we are going to make 4 equals to 5, then 3 equals to this number, that is the new number that has been formed, then 2 is equals to this number, 1 is equals to this number, 0 is equals to this number. Okay, so once we are going forward, once we are going backward, you can go first you can go forward and then go backward, or even you can go first backward then forward. Okay, to avoid plagiarism you can like change them. Okay, we can change the order of these. Then AR of j is equals to AR of j plus 1. Okay, once we are done with this, then we have to go to the third step. Okay, one is forward, first step is forward, second step is backward, and third step is check. What we're going to check if all the elements are equal. Okay, you know that, right? You know the checking. AR of I minus 1 is equals to AR of I. If it's not equal to, then boolean, that flag is equals to 1 and break thing. Okay, so now, and step 4 is if all are equal, then we print yes, if not, print no. Okay, let me tell you the whole thing once more. First you are going forward. Now remember one thing, in XOR, if A XOR B is equals to C, then A XOR C is equals to B. Okay, there is a very coincidental thing. If both the XORs are equal to C, then this XOR C is equals to B. Okay, so this is basically the thing that we are going to do for finding. So let's say A of I. Okay, so A of I XOR X should be, in this case when we are going forward, A of I XOR X should be A of I minus 1. Okay, so how we are going to find X? We are going to find X by A of I XOR A of I minus 1. So check this out, AR of I and AR of I minus 1. So this is basically X, and then we are going to make this XOR to the next element, because we know one thing, that if we are making this XOR when replacing it, then we have to also replace the previous element. That is, in this case, first we are replacing the previous element, so we have to apply the same thing to the next element. So this is basically, we are applying it to the next element, and then what we are going to do, make AR of I and AR of I minus 1 equal, right? Because we are making it XOR, so both of them becomes equal. So this is what we are going to do basically. So you may tell me that why we are going forward once and backward once. Okay, so if you just go forward, if you just go backward, it may work, but there is no guarantee that it will be working. So in this case, if we go backward first, so then this becomes 4 and this becomes 4. Okay, in the first going, this becomes 4, this becomes 4, and this becomes 7. Okay, this becomes 7. Now see, we have done all the things, but all of them are not equal. But if we go from here again, then this becomes 7, 7, and 7, because 2 XOR 4 is making some value X. If we XOR it with 2, then that becomes 4, and 1, if we XOR it with that number, it becomes 7. But when we are doing for 7, if we want to make 4 equals to 7, then 4 XOR 7 is some number which, if XORed with 4, gives 7. Okay, so this is the reason. This is the backward portion and this is the front portion. So after we have done both the front and back, you can guarantee it. Okay, so one thing, you can reverse this. Okay, you can first perform forward then backward, or you can first perform backward then forward, and then you have to check, and then you have to print. Okay, 4 is the print. So this is basically the pseudocode. Thank you.